Yeah, I haven't managed to make time for that.
Yeah, well, a lot of the team is focusing on Casper now, or they're they're diverting resources to that.
You got an example? I didn't realize that.
Let's see. Well, actually, I don't know who specifically. I mean, the I think wasn't it in the debrief where they were saying that they were diverting people to the Casper team, and that um, uh, resolving the Casper issues, they were sort of going to be delaying new feature development. So they're moving resources from feature development to Casper, as I understand it. But I don't know.
Okay.
Oh, yeah, node stability is the way I saw it phrased, but okay, maybe it's the same thing. I've got payment transactions working. It's not pretty, but I might be able to pretty it up a little bit.
You want to show us?
Yeah, when I get to my office. I'm not quite there yet.
Ah. Did anybody announce that we're here?
Oh, no, not in Discord.
Not widely.
All right. So what I've been up to, there's a few things. I'll share my screen. So there's a few sort of versions of it. I'm doing core development work.
Okay.
So I assigned myself a bug. It's kind of interesting. So I volunteered for this one, client-side application for app developers to use. And when I said, oh, I'm kind of already working on that. And so I started putting some kind of a command line interface on the stuff I've been doing.
Mm-hmm.
And then we got together with the app developers, and they said, well, we don't necessarily want a command line interface. And we had this meeting about a bunch of things that you need. Oh, that's already open. Ed Eichholt is working on some wallet stuff, and Chris Boscolo is at LifeID, and Paulo is at Proof, along with Udo, I guess. Or Udo might be working on the RChain.cloud, I'm not sure. So this was the second day. We were talking about, hey, what if you, how about being able to submit a transaction, like, to sending 10 rev to Alice, from Alice to Bob. And as far as I know, there's no documentation on how to do this, or, scant documentation on how to do this. So another version of that, signed basic wallet transactions, September 10, when I started thinking about this. The tricky bit about this is that, so this is the basic wallet contract, and you can get nonce and get balance. Okay, that's cool, and you can deposit, and that's kind of cool. But the thing where you have to do a digital signature is this transfer thing. This is when you take money out of the wallet. And you read down in here, and it says, okay, verify nonce amount destination sig. And then you go and you look at verify, and it takes the nonce amount and the return channel, converts the whole thing to a byte array, hashes it, and then does the digital signature check. And so I'm like, okay, I can take a list containing a nonce, that's a number and a number, and I know how to turn those into byte array using the protobuf stuff. I know how to do all that, but it's got this return channel thing here. Wait a minute. So that is, when we first started doing this, we could cheat, and we could use like a public name, like the word hello. But A, that's insecure because anybody else could listen on the results. And B, pretty soon that's just not going to work. They're going to take that out. Did somebody join? How do I get my, there it is. More, no, come on.
No, yeah, that was my computer making noises. I'm going to turn some things off.
That's fine. All right, put that over there. So we have to compute this digital signature over an unforgeable name, and typically the node makes those things up. I don't even know the unforgeable name before I submit my code that's going to have the signature. So I'm like, oh no. Yeah, that thing was the sort of outgoing purse, and those are usually unforgeable names, unless you want everybody to be able to get out your purse, which is not very good. So then I said, okay, well, we need a way to do that. And then so Kyle Butt just gave a presentation on how to do it at RCon 3. And as far as I'm concerned, it was totally black magic. It involved basically using a hashing function. Hashing? No. Oh, yeah, a hashing function in a little bit of a non-standard way. And I'm kind of like, cryptography tools, no user serviceable parts inside. So I was kind of stuck for a little while. And then it turns out you can predict what the unforgeable names are going to be if you have the deployment parameters, the parameters that you use when you're going to deploy the code. It's based on a public key and the timestamp. And so I added and we could have done this computation in theory in JavaScript on the client side, but figuring out how to do it was more than I could figure out. Joshy was working on it for a while too, and he didn't quite have it. anyway, so I just made a new RPC call on the server side that does the computation for you and gives you back the result. It's not something you should have to go over the wire for, but hey, close enough. Am I making any sense so far?
Yeah.
Okay, so anyway, there's this bit about predicting a thing that looked random, but it turns out it's not random, and it's still a little bit hard to compute. But so we got we called into the Scala code to compute it and got it to give us the results back. And so I added something in Casper source main. No, yeah, Casper. Hey, where's protobuf? Models source main protobuf Casper message. So there's now this preview private names thing where you give it the deployment parameters that they call it user, the public key of somebody. I'm not exactly sure whose private public key that is yet. They don't actually check signatures using it yet. So I can just use ABC or whatever so far. And then this is the deployment timestamp, and then this is how many names you want to preview. Oh, I'm doing this a little bit backwards. So this is the story going forwards, which is a little bit through the weeds. Let me do the magician's trick and then go backwards, because sometimes this is easier. So here I've got my client code to do all this stuff. And here I've got my node running, right? So I'm going to run my test. And it's going to do a bunch of stuff. And I'll sort of explain what it's doing in a little bit. Hello from remote call. Alice balance 100. And then it did Alice nonce -1, and then there was all this stuff. Payment result, it worked. Bob's balance is now 10. I should have gone back and got Alice's balance too. Okay. Ta-da! Okay, so how did he do that? All right.
Mm-hmm.
First of all, what's going on here? All right, so it goes. So there's two steps. One is there's a bunch of magic that happens at Genesis where Alice gets a wallet containing 100, right? And then Alice pays Bob 10. Okay, so the Genesis stuff. It's basically we're going to deploy a contract and get back a result. So here's this thing I call call contract. So let's this is the contract we're deploying, or the code anyway. And so the sort of magic part here is here's this new ret, and at the end we send the actual interesting bit back on ret, and I'll show you how to get that from the client side in a second. So might as well walk through this. I think it's not too much magic. We're going to go and get access to the registry. Here's the way you look things up in the registry and the way you insert things in the registry. And we're also going to get the standard error channel so that we can do debug prints. And then we're going to have a few utility things. and we're going to start by looking up what they call this system instances thing. And that happens to be its name. And you have to grovel through the source code to get that. Okay. So you look up the system instance registry thing in the registry. They got two registries anyway. And then you get back a pair. This first thing is some kind of like timestamp or revision number or something anyway. You sort of ignore that. And the thing that you want is the second part of the pair. How can this work? There's no rev channel yet. Oh, sorry, this isn't printing, this is looking up. Right, so you get this sys doodad back, and then you say, give me the rev thing. And the rev thing is a way to make empty rev purses with zero rev in them. And then I ran this node with a -- has faucet. So this is a faucet thing, which is basically a way to get non-empty purses, or non-empty wallets, actually. So while we're in testing phase, you can just print money.
Mm-hmm.
Okay, and then, so we ask for those two things, and then we get them back here. And then for debugging purposes, we print them out. So this is where they get printed out. So each of them is a sort of a write-only unforgeable name. So the only guys that can read from it are the people who wrote the contract. All right. And then we say, okay, please give me Mr. Fawcett, please give me 100 rev using, and the wallet should use Alice's public key, and here's it's the ED25519 crypto suite, and give it back to me there. And it actually gives me back of a list of either 0 or 1 things, a list of 0 things if I like spelled one of these things wrong or something. So I pick out the first item in the list, and I say, that's Alice's wallet. So here's Alice's wallet. And then I'm going to deal with that wallet on the client side, so I'm going to stick it back in the registry. So I insert arbitrary, and then I get back the URI that I inserted, and I debug that. That's this thing here. And I give that back. I put that on this channel here. And you might think, well, what good does that do? All right. So the trick is, back in our JavaScript code, before we deployed this stuff, the deploy has the timestamp and some other stuff. Let's see, where did we call a contract? Right, so this is the Alice init code that we were just looking at, and this is some public key that I chose arbitrarily. I got it from somewhere, I don't know. But as far as I know, it doesn't matter. And then I took the current clock, and that's my timestamp, and then the default payment stuff is just non-zero, flow price 0, flow limit 10,000, whatever. Okay, so then I do this call contract stuff, and that's my deploy stuff. And so this is where I'm going to actually deploy that contract. But before I deploy that contract, I can actually ask the node, what are the private names you're going to generate given those deploy parameters? And I ask for one of them, and I stick it in ret. So basically, I know exactly what this unforgeable name looks like at this point. Does that make sense? Anybody?
A basic question, and I'm not a coder. Ret, what does that represent?
It's a bad name. Well, return. It's short for return. But it's a name that I got to make up. So it could have been Steve Henley for all the computer pairs.
Okay.
The point is, when this code runs, this thing turns into some big random number, like one of these things. But after I run all this code, I want to get something back. I want to get this thing back so that I can deal with it later. Because these unforgeable names kind of go poof and stuff, unless you do something with them. Well, you can't. You sort of can't get at them except inside the scope where they were declared. So this ret thing here, once this code is done executing, nobody can ever get their hands on ret except that I no other Roland code can ever get its hand on ret. That would be forging that name.
Okay.
Unless I had sent ret someplace, and I haven't sent it anywhere. I've only sent something to it. Anyway, so I've got my fingers on it here, and then I can listen for data at name there, and that allows me to listen up for the end of this send. And then I sort of have to use some bit tweezers to get the pieces out, and then I printed that out. So this is the ret thingy, or at least that's the idea of it. And then I got back this doodad here. So row ID BAG, row ID BAG. Yay! So this was on the server end, and now I've got it on the client end. And so I logged it. I logged it again, I guess. Yeah, I logged it again as wallet URI. And then I pass it back. Okay, so now I've got, where was the, right. So now I've got Alice's wallet URI, this thing here. Then I'm going to go and do Alice pays Bob. Oops. So then there's this stuff that I did. I did this thing, mag proxy, which takes a URI and bundles up the business of looking up the URI in the registry, calling a method, and then giving you back the result all in one thing, and you can just use it from JavaScript. So after you've made this proxy thing, I can do await AliceWallet.getBalance, and it goes over to the other side, calls the stuff, and gets me back the result. So it's all just one line now, which is kind of convenient for the programmer. And then on the other end, what it did, the make proxy stuff made up this thing, looked up that URI in the registry because it has access to it there. It does a debug print. It says hello from remote call, and then it actually calls. This code here is generated by, it takes the name get balance and sticks it here and stuff like that. And so then I can log Alice's balance, and sure enough, she's got 100. And then I can call get balance the same way, and magic, and out comes -1. Okay, so now I've got I've got Alice, I've got my fingers on Alice's wallet, and I can actually do stuff with it. And then the amount I'm going to send to Bob is 10. And then in order to sign the transaction, I have to have Alice's whole key pair, not just the public key. I have to have the private key too. So this is the private key corresponding. And Bob's key, I didn't need his private key. I probably should fix that. But I just did it because it was convenient. And then this is my thing for deploying the actual payment. And again, I'm going to get a new timestamp. And I'm going to ask for 3 private IDs. And then we might remember that we had to do it was these parameters, the nonce, the amount, and the return channel that we were going to get hash and then sign. So this is the nonce, the old nonce plus 1, the amount, and then here's the return channel. It's kind of magic, blah, 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 but it uses this previewed private name. And so then getting all this stuff exactly, you have to get all this stuff exactly right in order for the signatures to work out. So I was pulling my hair out because I was sending the stuff in as bytes instead of hex, and this thing actually expects hex. And it does hex to bytes over here, and it doesn't tell you if you do it wrong. It just goes, it's just silent if you do it wrong, which is really annoying. Anyway, so those are the exact bytes that you have to hash and sign. Those are the ones there. And then, so I go ahead and actually sign them, and I log that for myself, so the signature is there. And then this is all this code that's kind of a mess. What does this do? It's got two things mixed together that I probably should separate out. This this does the transfer operation from Alice's wallet, but it also creates a wallet for Bob and sends it to him. I actually couldn't figure, you should be able to say, you know, Bob gives you his address, and then you say, okay, I'll send it to that wallet. But I don't know how to find his wallet given his address. So I had to make one for him. And then register it, and then the idea is that you then give, then you say, hey Bob, here's the registry URI of a wallet I just put money in for you. It's under your public key. So that was kind of a workaround. So I can look up Alice's wallet and the sys thing and the basic wallet contract and get my hands on those. And then I also have the stuff I'm going to want to sign, and I debug all that stuff. Alice wallet to hash and sign, all this stuff. And then we can grab the basic wallet contract. I'm going to make myself an empty purse because Bob's wallet is going to be empty. Yeah, if you pass in bytes rather than hex for a sig, nothing comes back. So this is when I actually do the transfer from Alice to Bob. Transfer amount, nonce, signature, and that's the signature I had computed over here. And then it's going to send it back. There's going to be a purse that comes out on the return channel, and it's going to tell me the status. And so then I print out the transfer status, if I win or lose. At some point, yeah, there's the transfer status, success. And in that case, I'm going to grab the payment purse and Bob's wallet, and print them out. Here's Bob's wallet and payment purse. And then I'm going to deposit the payment into Bob's wallet and get a result back. And then I'm going to insert Bob's wallet into the registry and send that URI back on Bob's wallet URI channel, which is way at the top here, and which I can get to on the client side. And then it prints out all that code here because it's substituted in the variable, the values like 10 and stuff down at the bottom. Prints it all out, and then I get the, what does this do? Oh, right. I want to get the deposit result and print that out. Deposit result true. And then I want to get Bob's wallet URI, and there's Bob's wallet URI. And then I'm going to do the make proxy trick that makes coding a little easier there. And so then I'm going to get Bob's balance and log it. And there's Bob's balance. And we should do one more thing, which is we should print Alice's balance. So the good news is it works.
Rather than doing a preview of the unforgeable names, couldn't you just return those with the result from the deploy?
Well, you have to compute a signature. You're deploying a signature.
Yeah. Never mind.
Bob's balance is 10 and Alice's balance after is 90.
Mm.
So the good news is it works. The bad news is that's a horrible amount of contortions.
Yeah.
So yeah, refactoring all this so that it's got a reasonable user interface or even developer interface is the next step.
And I guess the wallet now, isn't associated with the public key, or this is
Right. There isn't a path from the public key to the wallet. And what I've got here, the only thing I've got here is that I was able to make wallets and store them in the registry at arbitrary URIs. There is a thing after Genesis. So there's a thing where they associate a purse with your Ethereum address after Genesis, and if you claim if you use the claim check thingy, basically you sign a transaction and send it. They will give you a purse with that much money in it. I mean, they'll give you a wallet, but there's no mechanism for anybody else to find that wallet. I think. Let's see. Claim contract. There isn't even a way to send anything back. Okay, they got status out. They'll say, yes, it worked, but then, oh wait, there's a wallet store. Okay, there's where you claim it. Well, how do you actually get your hands on it? Oh, access, okay. So this allows me to find a wallet for anybody who had Rev at Genesis. But in my scenario here, Bob doesn't have, so I could have gotten Alice's wallet. If I had used this thing, which I should have, because this is the way Genesis is really going to work, I could have looked up Alice's wallet by public key. I would have had to claim it first. But Bob doesn't have anything at Genesis. He's just a new guy. He just made up his 12 words one day, right? Mm-hmm. And he gave me his public key and said, send me 10 Rev. So his wallet's not in here.
There's could be a way to add a wallet to the wallet store. No?
they could change this code. Yeah, I'm not sure they want to have an array of all the wallets in the world, though. That would be very expensive to add something to that array. Because as far as I know, the only way to add something, the data structures in Rolang are all immutable. So the only way that you update this wallet store is that you read it, you create a new map with an extra entry, and then you write the whole map back. And so as time goes on, it gets more and more expensive to do that operation because that map gets bigger and bigger. So claim your wallet early.
Yeah. Well, I'm thinking about the DID directory. I think it has to be a recursive map. Make it manageable. Perhaps that would.
Yeah, the registry itself, I think, is a try.
Oh, wow.
So,
what is it?
a try, like tree.
It's
or radix tree. Like if you want to store words in a dictionary, you put the first letters at the top level, you split by the second level, next you split by the third level.
right, which is essentially a recursive map.
Yeah. It's just that if you go looking in Stack Overflow for recursive map, you won't find it.
Yeah.
If you look for radix tree or try, you will.
So what would you call the file system structure?
Yeah.
It's not exactly a try, but that's the DID structure is like the file system structure.
Hmm. Oh, I guess. I'd have to put something in the wallets.txt file of the node. Then I could probably do the wallet check thing. Because I think the node that I booted up here is one that Joshi figured out. It basically creates its own little world, it does its own little genesis. So if you give it a wallets.txt file, then it will know how much money Alice has.
I would expect we would want a way of determining a wallet associated with a public key.
I suppose I should open a new ticket on that, huh? That was what I said here. The biggest wart is that I don't see how Alice can look up Bob's wallet from his public key, let alone his address, which is a hash of a public key. Yeah, it's kind of interesting because the basic wallet contract just takes a public key. When you create a basic wallet, you give it the public key. But the wallet check knows how to do all the stuff to go from an Ethereum address to a public key. Oh, it's the other way around. It knows how to go from a public key to an Ethereum address because you can't go the other way. That's a secure hash function to go the other way. So this thing knows how to deal with both Ethereum addresses and public keys. Oh, right, because the node knows about your Ethereum address, but then when you go and claim your money, you have to give it your public key, and then it checks to see that that public key corresponds to that ETH address, I expect. Where's the doodad? Claim contract, yeah, public key. So then it's gonna hash your public key and check to make sure that it's the same as the ETH address.
I thought the ETH address was the public key. I mean, how could if I don't know a public key for my ETH addresses. I mean, it is the address.
No, it's a hash of an address. I mean, hash of a public key.
So how can I ever find out what the public key is?
You in general cannot. The address is the last 20 bytes of the hash of the public key. Accounts are indexed by their address.
I guess if I can't find the public key, I don't know how I can use a Ethereum address as an account on RChain.
Well, it still has relevant properties. So if I tell you my Ethereum address, you can check that I'm the owner because you can say, okay, please sign something and send it to me, right? So I have to sign something with the private key corresponding to the public key corresponding to the address. And then I send you both the public key and the signature, and then you can check that the public key corresponds to the address, and then you can check the signature.
Yeah, I'm losing something here. I don't know how I can send anybody a public key if I can't figure out what it is.
Well, the owner knows what it is.
Well, I own a bunch of Ethereum address, but I don't know what the public key is.
No, you're in a world of hurt. But you have to have the private key, right?
Yeah.
Well, you can derive the public key from the private key.
Ah. Yeah, I knew that.
Yeah, one of the things I discovered, maybe the hard way, was that you cannot go from your private key to the 12 words. You can only go the other way. I don't know if I've ever read this. I've been
Um,
This is my collection of things that app developers want or need or something.
is there any movement in the idea of moving off Elastin onto GitHub?
I've seen some talk of that for the RChain improvement process, but otherwise, no. I haven't seen any talk about that. Did you hear about it somewhere?
The RChain improvement process, I think it's the only place, but it seemed like it was very generally supported. So I was wondering if you knew anything more.
No, I mean, the development team has got 2 years of history in this thing, so I don't think they're moving anytime soon.
So I guess I misspoke.
What's been going on anywhere else?
Well, I'm stalled with getting the PHP issues. For some reason, some channels, when you go to the dashboard, it doesn't show them. And you go to all and you see there's channels missing. But from other channels, all the channels are there, all the tiles are there. The
This
activity.
is social ledger or bounties or what?
Social ledger, yeah.
Okay.
And they got a lot to do there.
Are you coding in PHP by choice?
Legacy, more or less.
Yeah.
Almost all the new work is in JavaScript currently, but using Vue. A lot of client-side stuff.
Right.
But we still have the prototype, which was done in PHP.
Right.
And it's basically working in most installations. I just have this problem in the RChain installation. So it's not something we really plan to develop, except maybe add some small improvements. But basically, all new development is going on the portal side and away from the slash dig. Quiet. Quiet.
So I'm down to one dog now. I guess he's slightly off camera.
Whoa. What are you barking at?
Evo's old enough that he's happy to mostly sleep in.
Yeah. Boo's getting on. He couldn't get himself to jump up on the bed last night.
Oh boy.
It's just pretty high. Yeah. What are you doing, Boo? Come on in. Yeah.
All right. Well, I'm probably going to run along now.
Yeah, well, I thank you much for that tour. I think it's very valuable, and thanks for going through it with us.
Sure.
Yeah, thank you, Dan.
You're welcome.